And I think we are live. Hello, everyone. Welcome to day three of our first ever TestMu Conference 2022. I hope you had a really exciting day, 2 days of great insights, great talks, and and really appreciate you guys sticking us with so far. For this day as well, we have around 10 plus sessions, action-packed sessions planned for you. So stay tuned. Today, I have with me Gandhali. She will be helping us out with very in-depth insights on how we can use GitHub specifically for test automation. Everybody knows here GitHub, it's like one of the most ubiquitous code management tool, but GitHub is not just that. GitHub has so many functionalities, and one of those would be to help us out over test automation specifically. So Gandhali would be there to help us out. So to go a little bit more about Gandhali, she has over 20 years of experience, more than 2 decades of experience in leading multinational companies, specifically around in the technologies. She is currently leading GitHub Enterprise Advocacy Charter, specifically in the APAC region. And prior to GitHub, she had around 8 years of experience at Microsoft as an engineering leader. So Gandhali, the stage is all yours. Over to you.
Thank you, Mudit. And I'm just gonna share my screen. And once you confirm, can you see my screen, Mudit?
Yes, sir, we can.
Okay. So, good morning, good afternoon, good evening, everyone. I am given the understanding that there are people joining from many different countries, every different time zone. So, thank you for being here and thank you for deciding to attend this session. Today, I'm going to talk about GitHub for test automation. My name is Gandhali Samant, and as Mudit introduced me, till last week I worked for GitHub, but today I'm actually back in Microsoft looking after a cloud solution architect team. But I have lots of experience with GitHub, and I have my favorites. I There are some GitHub features which I really love. So when I was asked to give this session, I was excited to come and talk to you about what I love about GitHub for automation. So without further ado, let's start. So, as we all know, automation is a powerful tool, right? It helps us reduce time, it helps us increase productivity. Uh, but automation can be tough and can sometimes prove to be costly if not done right. In any automation, there is always an overhead. When you start automation, you spend a lot more time automating, you spend a lot of more efforts, costs automating. So what if you have something where the automation time can also be reduced, and you can get an automation tool to quickly start automating your workflows. And that's where, as I said, my most favorite feature of GitHub Actions. They can help you automatically build and test your projects, which is our today's topic. But GitHub Actions are a lot more than that. GitHub Actions can help you in many different things and automating many different workflows. So today, first 15 to 20 minutes, I'm going to spend on talking about GitHub Actions. I'll walk you through the architecture, how do you write the actions, where all those are useful. And then we'll dive into GitHub Actions specifically for test automation. We will see different test automation scenarios, right from UI testing, testing using different framework, and as well as browser testing. So let's get started. So GitHub Actions, what are they? One second. Okay. So before we actually look at GitHub Actions, right? I wanted to put this diagram in front of you. Most of you have seen this somewhere or the other in your software development life, right? This is the standard SDLC: plan, code, build, test, release, deploy, operate, and monitor. But there are many things within this software development lifecycle that could be automated using GitHub Actions, and which can make your life very easy. So starting with planning phase, we have a lot of issues, we have project boards, and there are a lot of things that could be automated. So one example I always give is one of our customers who had a product feedback site where an external customer could give a product feedback. But they had built an automation where that product feedback, as soon as it is created, it directly gets into a repo and becomes part of your backlog. So you don't have to manage and kind of sync two different systems. You can automate workings of your project board. As you start coding, you can obviously automate your PRs. How do you label them? How do you close issues with PR? And obviously, as you get to build and test phases, they are like the obvious candidates for any kind of automation you would want to do. So compiling, building your code, storing artifacts, automating test suites, if you want to use linters, consuming packages, right to in your release and deploy phases where you can publish your releases, you can upload artifact, and lastly you can deploy your application. All of these stages, all of these workflows, you can automate a lot of stuff in these different life stages use, using GitHub Action. So, GitHub Actions let you automate, customize, and execute your software development workflows. They are stored as code, so you can do the version controlling as well as they could be very easily reused. They give you live logs and visualized workflow execution. It also gives you metric bits. What I mean by that is, say, for example, you have an app, a Node.js app, which you want to build using multiple versions of Node.js. You can store that information as a matrix, and your GitHub Actions can do that build actions for different Node.js versions. It also comes with a built-in secret stores. Many times we have connection strings, we have environment variables, we have authentication tokens that our code requires to access different resources, and that's where this built-in secret store comes in handy. So you don't have to store your secret within your action, you store it in a safe place and you just call it using a parameter. And lastly, there is an option to use GitHub hosted runner, or you can use your own runner, and we'll get a little bit deeper into that. So how do actions work? Like any other automation, it starts with an event. What is an event? Event is a trigger. It could be anything that can tell your workflow to wake up and start executing. It could be something like creation of an issue, or it could be something like a pull request. It could be a scheduled event, or it could be a manual event. But event is the most important thing because that is what is going to trigger your action workflow. Then we have what we call as workflow. Workflow consists of multiple jobs. There could be one or more jobs. And all these jobs by default run in parallel. If you want to run them sequentially, you may do it so. Each of these jobs, again, is a collection of multiple steps. Now, all these steps within a job, they always run sequentially. And within those steps, you have what we call is an action component. Now, when you think of action component, it's kind of a task. Say, for example, you want to check out your code, or you want to build your application, or you want to deploy your website. These are all individual tasks, and each action can be used to do these tasks. Instead of actions, you can also use shell commands. So, for example, if you want to run a command to do some testing, or if you want to run a command to run some script, you can use that within steps. So now you have events and you have workflow, which is the structure of your action code. Where do you run it? That's where the runners come into picture. Runner is nothing but a VM, just a simple VM, which is constantly listening for the next available job. The moment it finds a job available, it will pick it up and start running. Now, one important thing about runners is it takes one job in its entirety. You cannot break up job between multiple runners. The benefit of it is you can use the file system of runner. You can store data and pass data between two different steps because it's all in one environment. So runner runs these actions and it also logs result. It creates a step-by-step visualize log and sends it back to your GitHub repo. So as your action is executing on the runner, at the same time in live in real time you can watch it on your GitHub repo how it's working. So we looked at the architecture. Now let's look at the structure. How do we create this workflow? So it starts with a simple YAML file. You can name it anything. I have just named it workflow file name or .yaml, but the location is important. This location has to be the root of your GitHub repo /.github/workflows. That's where all the actions or workflows reside. And this is a standard structure of a YAML file. Let's go one by one of each part of it. The first one, as always, is the event. As you can see here, this is an action or this is a workflow that we want to run on push event. You can also specify push or pull on particular branch. And as I said, there are multiple different types of events that you can define here. The next thing we have is a job. And then within job, you can see there is a definition for the runner. Now, what do you see here is runs on Ubuntu latest. What does it mean? It simply means that this job is going to run on one of the default GitHub runners with Linux Ubuntu operating system. Ubuntu-latest is just a label to identify that runner. Then, as we saw earlier, we have steps. So here you can see there are two steps. One is check out your code, and the other is lint code base. So each step could have multiple parameters. It could have name, it could have ID, it could have environment. So these are your steps. And if you remember that action component within your step, this is what is your action component. So here what it is doing is this step is invoking this action checkout to check out the code of the current repository. And this next step is actually using this next action superlinter to lint the code base. Now for these actions to work, we need a few variables. So for example, you need some environment variable. You see here we have defined some of the environment variable, and there is a GitHub token which is stored in the secret store that I again talked about earlier. GitHub token is simply a way for your action to be able to access the GitHub APIs. That's why you need the GitHub token. Now, if you want to go deeper into events, you will see three different kinds of events. Uh, Webhook events, which are the standard pull requests, issues, pushes, those kind of events. We have scheduled events. So, for example, if you want to run a build job every Saturday at 10 p.m. in night, you can just create a cron sequence for it, and it will take that and schedule it accordingly, and at that time it will go and run. And it also has an option of running a manual event. Now, why manual event is important? Many times when you are developing your actions, you are trying code and all that, you will want to run your actions just for testing, right? You are not always going to create a push pull request or do a push to the code. So that's where the manual event comes in very handy. Next, as I talked about, and we are gonna go a little deeper into runners. So, as I said, there were two kinds of runners. One is a GitHub hosted runner. GitHub hosted runners have a kind of standard, I would say, configuration. It has two core GPU, it has 7 GB of RAM, and a certain disk space, and three different OSs possible: Windows, Linux, and Mac OS. And it comes with tons of software pre-installed on it. But what if you want to use a VM with, say, some N series VM, or something with GPU, or something with a custom OS that you want to run on? No problem. You can create your own VM, you can create your own custom label, and you can have your self hosted runner where your actions can run. You can do it very easily. So, either GitHub hosted runners or self hosted runners. And then when you look at these actual actions, right, there are three types of actions. A, actions residing in public repository. Anybody can go and use them in their workflows. B, actions residing in the same repository as your workflow. These are local actions. and they can only be used within your repository. Nobody outside your repository can use it. And then third is the published Docker container images. So if you go to say GitHub Marketplace, you will see lots of published container images or published actions which anybody can just call and use in their workflows. So, to recap the architecture of the GitHub Actions, you have events which trigger the workflows, and workflows refer your actions which are run on a runner. That's how the actions work. So I want to show you some of the third party marketplace actions which you can use when you try creating your workflows, and then we will look at some demos. Okay. So let me just stop sharing my screen and go here. So I'm going to show you GitHub Marketplace. Okay. So this is GitHub Marketplace, and if you just try to say do test automation, I'm going to remove this filter. You will see many different actions which are already created. If you just click on any of those, right, say for example setup automation testing, it will also tell you how do you use it in your workflow. So it will tell you which parameters to use, it will tell you what are the different versions available, which is the latest version. So if you remember, I showed you the super linting action in one of the workflows, right? So if I just go here, if I search for this, I will find this, and let's go inside and see how it is structured. So when you go for any of these, marketplace action, you will generally find some really good documentation, which will tell you how to use it. It will also have some kind of, kind of a code sample to use it within your workflow. It will give you a workflow sample, but it will also give you link to the GitHub repo for the code of that action. So you can actually go and see how that action has been written, right? And every action has something called action.yaml in it, where you can see this is using Docker and this is the Docker container image that I talked about. So anytime I use this super linter action within my workflow, this is the Docker container that runs and goes and lints all my code base. So this is what is I wanted to show you for GitHub Marketplace. Now next I want to show a few of the demos using some of the code that I have written, and we will also see how we can do test automation using action. So I'm just gonna pull up Visual Studio here, Visual Studio Code, and I'll quickly show you a project that I have. This is a .NET project. I don't know how many of you know .NET, but I have been in IT for long enough that .NET has been my first language. So I'm going to show you one demo in .NET, but I'm also going to show you a demo in Node.js. So this is my .NET project. If you look at this, it's a console application which tells me that the string that I'm entering, whether it is beginning with uppercase or not. A simple action. A simple code. But what is important here is I have a library, which is basically this function which calculates whether it is a string with starting with uppercase or not. But it also has a test library. If you can see, I'm using the Microsoft Visual Studio unit testing libraries to create this testing. So I want to first show you how this testing will work in a GitHub action. So if you look at this code, I have three actions here, and if I quickly try to run this, .NET build, and I will do .NET test. You might be familiar with .NET Core framework, which I'm using here. It is telling me all my tests have passed. So if you just want to see how this code look, I'm gonna quickly run this code and show you. And if I say add something, it is gonna say it's not starting with uppercase, and if I do this, it's gonna do it. So this is simply the code. Now if I go to the to my GitHub repo, if I go to my GitHub repo here, you will see this is the workflow. This is the same repo that I showed you, .github/workflow at the root of your repository. And this is where I have my YAML file. So if you look at my YAML file, it has the triggers, the events. So I'm going to run this on a push when there is a push on main branch, when there is a pull request on main branch, or when there is a workflow dispatch, which is a manual trigger. If you look at the steps, the first step is obviously the checkout of the code. Second step, since it is a .NET project, I'm setting up .NET SDK on the runner that I'm going to run. And I'm doing the same thing, .NET Restore, .NET Build, and .NET Test. So if I just run it here, I'm going to go here. And because I have added workflow dispatch as a trigger, I'm going to get this button, run workflow. So I'm going to run this, and we'll go back here, and you will see a build has started. And it will also tell you that this build has been manually kicked off by G Samant. So, it gives you all the telemetry of how the build was kicked. Was it kicked by a pull request or a push request or manual, and who was the one, triggering it, all that. So now you will see as it's working on a runner, I'm getting all the logs here within my GitHub repo, and you will see it did the testing and it completed the job. Now, why do we want to automate this? Why do we want to put test environment or test conditions within our action? See, you have a big team and many people are changing the code at the same time, right? If you set up a correct branching strategy, the correct way would be that every developer will create their branch and they will do a pull request when they want to kind of merge any code. So this will stop your code from getting merged as soon as it detects something has failed. So let me just quickly show you here. I have this, I'm going to introduce an error in this code. So I'm going to say is lower. So obviously it is going to fail all my tests, right? So let me just save this. Oh, 1 second. As I said, the correct way would be to create a new branch and do it, right? So let me just testing, and I'm going to create it from main. And here in this branch, I'm going to change the code. Roar, S, and I'm going to go here. I'm going to just take my CS file and stage that change. Is error. I'm going to commit it here. Once I commit it, I'm going to push it to the main branch. But since I'm doing it from a different branch, it is going to ask me to create a pull request. So if I do this, okay, let me go back here. Okay. So now it is telling me that testing has recent pushes less than a minute ago, compare and pull request. So now I'm going to create a pull request. Now you will see it will first check the ability to merge. It will say this branch has no conflict. But as soon as that has checked, it is also going to trigger this CI workflow, and it is going to test whether my all my unit tests are working or not. And since I have introduced an error, my unit tests are going to fail, and this code is not going to be merged. It is going to stop it at pull request only. So if we go here and if I go here, it's It's failed. It is telling me that, two failed, one passed, and this is an error. So it's not going to let me merge my code. Now what I will do is I will go here, and as a good developer, I will fix my error. Yes. I'm going to again stage this. Fixed error. I'm going to commit this. And I'm still on my testing branch. So after I commit this, I'm going to push it to the main. And now I'll again get a request, pull request. Okay, so oh, something didn't go through. Did I commit this? Yes. Push to. Okay, yes, I am here on my pull request, and this has again kicked because I committed another commit, right? You can see my second commit, which is fixed error. And now it is saying all checks have passed. This branch has no conflict, and I can just merge this and delete my branch, and I'm good. So this is how you can just use the testing that any framework gives you, add it as a part of the a pull request step inside your GitHub action, and you will always make sure that unless all your unit tests are passed, you will not even get a merge option. Now I want to show you another demo with a Node.js application. Here I'm going to use a different framework. So here I have a Jest framework. I don't know whether you guys might have used it or not, but let me just pull up the code. Okay. So here again I have a web page now. If you see here, this is a web page. It is going to take a couple of numbers, and it is just going to add them. For adding, I have a function called calculator.js. One second. Okay, sorry, I'm showing the wrong one. I need this one. Okay, so I have a calculator.js, and then I have calculator.test.js, which I'm going to run using Jest framework. So if you see here in my package.json, I have added scripts test is equal to jest. So basically, whenever there is a npm test command, I want to run the command jest to be able to test and to be able to run these tests. Okay. So if I look at my code here, if you look at my action here, you will see a little difference because now we are using a Node.js. So, we are using this node setup node action, which will set up my node environment with a specified node version. And then it will do the npm install, build, and test. So it will do npm run, it will build, and npm test. So if I just run this, let me just show you the last run. It will again otherwise take time for running. So if you see here, it has again it has used jest to, you can see here the jest command, because that's what I have specified in my package.json. It has used jest command, and it has run the two test cases that I had created, and because it has passed, it is showing me that the build and test is passed. If I again introduce some error, it will stop this and it will not let me do a pull request here. Just wanted to show you that you can use different frameworks also, as long as you can just integrate them, and your code is correctly set up to like the with to use those frameworks, you can use all of that within your actions also. Whatever you run on your local, all those commands could be directly run in your GitHub action workflows. So this was the second demo. The third one I wanted to show is something a little bit more. And I was having, so it was working fine, but as per Murphy's law, it just stopped working like 2 minutes before this session started. But I still want to go ahead and show you what this code is doing. So this is again the same project, but here what I have is a test.js file, and I'm gonna bring this different code here. I don't have a jest framework now. So you will see that I don't have the calculator.test.js. Instead, I have something called test.js. And this is using the LambdaTest platform. As you see here, it is taking it needs Selenium WebDriver. It also uses my username and key. And then it creates all the LambdaTest capabilities, and then it goes and runs this in a different browser. So if you just go back here, I'll quickly show you the Lambda test dashboard as well. Okay, so this was the last test I ran. What it is doing here is, it is first, okay, let me just show you the code here. Okay, this is what you can do to do your UI testing, right? So the earlier tests that I showed you, they were your functional testing, they were your unit testing. You write it to make sure that your code coverage is good. But what if you want to test your application on multiple different browsers at the same time, right? You need a tool like LambdaTest. So here, what it is doing, it is simply using a URL. Uh, then it is using this driver, Selenium WebDriver, to find the elements. It is successfully, it is inserting some numbers, and then it is just checking whether the UI functionality is working or not. That's all it is doing. So if you go back to the Lambda test dashboard, right? This is the test I ran last time, and you will see it is all passed. And if you will also see a complete kind of video of what happened. So if you look, let me just go back, and this goes very fast. But if you see, it went to the website, and it actually clicked the result, and it showed the result here. So this gives you a complete video of what this how you are testing in browser working. How do you do it in GitHub Action? So I'll quickly show you what different things I have done in the action here. What I've done here is, let me go to the code, and I will go here, and I'll show you. Okay. Okay, so here you will see that I have some extra environment variables. So since I want to deploy now this web app to Azure, I have the Azure web app name, I have the Azure web app package path, I have a node version. Uh, this is all common checkout and setup node, but you will also see there is something called a start tunnel step. This gives you a tunnel to run a test on your local host using Lambda Test platform. How do you find it? You can just go here, and I'm going to quickly show you again. This is a published action on GitHub Marketplace. So let me just quickly show you here. Test action. I need on Marketplace, yes. So if you look here, it will tell you that it action seamlessly integrates Lambda test tunnel, and you can do the Selenium test on 2000 plus browsers. All this information is there. So this is what I've used here. So if you look at here, I have created this tunnel, then I'm doing the testing, and I'm then deploying to Azure Web App. So as you will see, there are some web app, some secrets here, and yeah, I wanted to also show you secrets. Here, to set up the tunnel, you also need your user ID and your Lambda test access key. So where do you set it? If you remember, at the very start of the session, I talked about the secret store, right? For the GitHub Actions, you go to settings, you go to secrets, and you go to actions, and this is where you can store all your repository level secrets so that they are not exposed in your action file or in your code. Here, these are the two secrets I need to set up my lambda test tunnel. This is a publish profile which I need to authenticate my user to be able to deploy the application to Azure Web App, and this is where you store the secrets. So with that, I think these are the three demos I wanted to show. Let me quickly go and see if there is anything else. I think we are almost at time. So we did the live demo. Uh, Go to this place, lab.github.com. There are a lot of things that you can do with DevOps with GitHub Actions. Uh, you can run, and all these GitHub Actions are completely free for public repositories. So if you have any open source code, if you are using any, you know, your pet projects on public repositories, all this goodness you can use for free, and you can try it here today. So with that, these are my coordinates if you wish to connect with me, and we are good. So I can take some questions if there are any.
Thank you, Gandhali, for going through the whole session. It was really, really insightful. GitHub Action has been one of my favorite feature sets of GitHub. There are a few questions in our Q&A session. I'll be showing them up on stage, uh, and it would be helpful if you can help us out with the answers, right? So one of the first questions I have is from Manish.
Mm-hmm.
This is a very interesting
Mm-hmm.
question. I'm showing it on stage. Can we trigger
Mm-hmm.
pipelines of a repo from another repo? So, for example, if you're running automation that is written in a separate repo, but trigger it from a development repo pipeline.
So no, GitHub Actions are local to the repo. I mean, they have the control on the code of the repo. There is something called nested repositories, and that's where you can try this. I haven't tried it. I can try and come back to you. But in a normal way, GitHub Actions generally run within the scope of its repository. So they can do anything with the code. Uh, the code that resides in the same repository where the action resides.
Awesome. Another question from Abhinash from Binmile. I'm showing it on stage. What are your some of the best practices when working with GitHub Actions? That is, as per your experience.
I would say some of the best practices, anytime you want to write your workflow. So, first of all, actions could be confusing the way we use the word. So, GitHub Action is a feature, but what I showed you are the workflows which actually use the pre-created actions, right? Which are on marketplace or which could be on public repositories. So, first thing I would say is anytime you are building a workflow, first see if the steps or the actions that you need within your workflow are they already available, are they publicly available. That will that will reduce a lot of your efforts and time. Secondly, there might be scenarios where you have to create your own actions or you have to create your own tasks. At that time, think about whether they could be publicly made available. So if you create it in a Docker container and publish that container, that would be a good way to kind of validate your code, kind of make it open source, and get feedback about it, right? And obviously a lot of things like security wise, you have to take care of your secrets. So make sure your secrets are always stored in secret store. If you are writing actions which are specifically for your enterprise usage, you might want to not make them public, you want to keep them local, and at that time you can make the scope of the secrets also at an organization level. So there are a lot of different things that you can look at, and depending on your use case or where you are using these actions, whether you are using open source code or whether you are using it for any of your enterprise or your company things, there could be different considerations of best practices.
Awesome. So this is another question that is, I'll say, a little bit related to the our first question. Is it possible to deploy a staging test environment within GitHub and run post-deploy end-to-end tests?
So when you say staging test environment, right, the runner is actually going to execute your your actions, but it is not going to have a deployment environment. So GitHub does not host the environment as such. You will need some environment on Azure or on AWS or somewhere to actually run the end-to-end test. What GitHub runners can do are the tests which are which are the functional testing, which comes as a part of your code coverage testing, all that. Yes, that could be run on GitHub. That's where the tool like LambdaTest could really come in handy, because it gives you an option of actually deploying your site to localhost and do the end-to-end testing on localhost before deploying it to cloud. So uh, try that. That could also be one option.
Now, to add in that related to Lambda test, so we have a GitHub action for running that tunnel, as Gandhali also highlighted. You can use that GitHub action to deploy a localhost version in that runner and run end-to-end test across that. And based on the results, go on to next events, right? Okay, another question that just had from Michael: how you manage the latency between GitHub runner or device farms?
I can't see your question, Mudit, and I can't hear
Sorry.
you. Can you? Okay. GitHub runner and okay. So first of all, it's not a GitLab runner; it's a GitHub runner.
Yep.
Okay, see, GitHub Runner is just a VM which is going to run the action task. It is not going to run your application, right? It is going to run the task like checking out your code, building your code, and then deploying your code to a certain environment. Whereas Selenium Grid or Device Form is the environment where you can do that testing, right? So uh, there wouldn't be any latency, because you are not actually doing the same thing between them. You runner has a specific task of checking out, testing, and building your code and deploying it to somewhere, whereas Selenium Grid or Device Farm has a different task of doing your end-to-end testing, different browsers, all that. So there are two different, I would say, separate concerns here.
Awesome. So I have another question. This is related to the security, and I think the security vault, as you showcased in GitHub, that kind of answers this. But what is your opinion? How GitHub has helped in securing open source software?
So see, security is one of the biggest concerns nowadays, right? And if you look at GitHub, there are so many features related to GitHub security which are available for free for open source software. So things like Dependabot, things like CodeQL, things like secret scanning. All these things are basically helping you shift left, as we say, shift left on security, right? Make sure your code is secure as soon as you are writing it. So I would say, maybe I can find a link and then post it somewhere with it. But there is some really good documentation on GitHub Docs which tells you what are the features available for free for open source software. Just for simple things like dependency checking, right? Every time you will do a dependency checker, you will know if any of your dependencies have become secure, vulnerable. The depender bot will go and automatically fix it if you ask it to. All these things are already there, and GitHub is continuously improving and adding more and more feature to keep the software secure. So if you are an enterprise user, we have a complete SKU of GitHub Advanced Security, which is very very tuned to GitHub Enterprise SKU, which is for large enterprises uses. But as I said, open source, many of those GitHub security features are completely free, and just check them out.
Awesome. So we are nearly short on time. I want to take just one last question, and I think this is a fun question. More of this. What would you say is the key Git command you need to be aware of?
Okay. Um I think you have to remember everything, right? I would say, I love git clone, I love git commit, git add, git pull, git push. It's everything. Um, I sometimes
Also,
even today get confused between I mean, sometimes the syntax can be a little difficult on the commands that you don't use every day, but I can't pick a favorite. I love GitHub as it's.
what about Git push force?
Oh wow! Why would you do that?
Awesome, awesome. So I think we have just hit the time. So thank you, Gandhali, for taking the time out and walking us through the great GitHub Actions features. So to sum it up, GitHub Actions is an all-around holistic CI/CD features that can help you with event-triggered workflows, specifically that can have to be run across self-hosted or even GitHub-hosted runners. GitHub-hosted runners is a great feature. In addition, do check out the GitHub Actions Marketplace. You will find a ton of small triggers, small events that can even workflows that can make your life easier. My favorite one out of them is npm install, the complete npm install GitHub runner that can GitHub action that can help you install across the whole npm package in a single go, right? uh, so as we close the session, I do want to shout out to our partners for helping us out across promoting this event, for all the attendees to with sticking us so far, making our 2 days success. And we have a lot of action-packed sessions for this day. And also thank you, Gandhali, for walking us through the such an insightful session.
Thank you. Thanks, Mudit. Bye, everyone.
Bye, everyone. Have a great day, Ed.